Hey guys, so I'm starting where we left off. We talked about the hydraulic lifts and the formula you're supposed to use right here. Your math looked pretty good on the worksheet, so you should be good. So now we're going to talk about Bernoulli's principle. According to Bernoulli's principle, as the speed of a fluid increases, the pressure within the fluid decreases. So this is how a plane lifts off or has its lift, is because the air, basically the fluid, over the wing is faster than the air under the wing. So it creates a pressure difference, which gives the plane a lift. You can do this with a sheet of paper. If you put the sheet of paper right under your lips and, it's sticking straight out kind of. So, like, put the short end of the paper underneath your lips and then blow really hard. The paper will lift up because the air over the top of it is going faster than the air underneath it, so it creates a pressure difference, so it gives the paper lift. So wings and lift. The air traveling over the top of an airplane wing moves faster than the air passing underneath it, so this creates a low pressure area above the wing, and then a pressure difference between the top and the bottom of the wing creates an upward force known as lift. So because the air is going over the top of the wing so much faster than underneath, it creates a low pressure system on the top and a high pressure underneath, and it gives it a lift. Okay? In the book, there's a really good little thing about it, and it'll show you some pictures and stuff. I wish I could show you this in class. Race cars have an upside down wing known as a spoiler. If you look at the back of race cars, they have a spoiler. A spoiler in most cars, like if it's just a street car, it's just for looks. But a spoiler on a race car actually works as an upside down wing. So a wing gives it lift, but an upside down one is going to push down on it to give the tires better traction. So when they go around corners at a really high speed, it basically pushes the car down so they have more traction on the road. So pretty cool, huh? All right, spray bottles. Now, this is not a spray bottle like where you squeeze the top and use it. This is like the spray bottle in the book, okay? The only example I can really know of is like when you are fertilizing your grass and you buy the Miracle-Gro kit kind of thing where it hooks onto your hose. Basically, that's what that's in the pictures in the book, and it's a really good one. So basically, again, your water coming out of the hose over the top of the fertilizer is going so fast that it creates a pressure difference again, so that it pulls up the fertilizer, concentrated solution, into the water from the hose. So its design is based on Bernoulli's principle. Pressure differences draw the concentrated solution up into the fast-moving stream. Please, on both of these, you've got to look at the book. I don't have the page right here, but you've got to look at it to help you get a visual for this. Okay? All right, I'm going to start section 3. A buoyant force. Buoyancy is the ability of a fluid to exert an upward force on an object placed in it. Buoyancy results in the apparent loss of weight of an object in a fluid. So you know that if you've ever, put somebody on your shoulders or pick somebody up in the pool, they don't weigh that much. But as soon as you lift them out of the water, then they go back to their normal weight, right? So like if you put somebody on your shoulders and you're underwater so they can get on you easier, and then when you stand up, it's like, oh my God, right? So it's because buoyancy makes them feel like they don't weigh as much. When an object is submerged in water, the water exerts an upward force on the object, making it easier to lift because it feels like they've got less weight, right? This upward force, which acts in the opposite direction of gravity, is called buoyant force. So you ever put a ball underneath the water and then let go? The ball goes shooting out, right? You got to be careful because your face is right there. It hits your nose or something, or makes you bite your tongue. I've done that a couple times. All right, so basically, gravity is going to push down on things, but buoyant force just pushes up on them if you're in water or basically a fluid, okay? Archimedes principle. According to Archimedes principle, the buoyant force on an object is equal to the weight of the fluid displaced of the object. So the buoyant force is what's pushing up on it is equal to the weight of the object displaced by the object. Okay, so weight of the fluid displaced by the object. So what this means, let me see how to explain this again. The weight of the fluid displaced. So like, like when you get in a bathtub and when you get in, the water goes up. If you took that amount of fluid that went up, like if you marked it from where before you got in and then marked it after you got in, if you were able to take the weight of just that fluid from the beginning to the end point, that is your displacement. We talked about this in class, right? So if you took the weight of that, it would equal the buoyant force of the object. So when an object is submerged, it pushes aside or displaces a volume of fluid equal to its own volume. We know this. We did this with the little rocks in the classroom, right? Because you have to, if something's an odd size, and you can't just take volume, which is length times width times height, you have to take volume using displacement. So when an object floats on the surface of the fluid, it does not displace its entire volume. The floating object does, however, displace the volume equal to the volume of the part of the water being submerged. So like, let's say a boat, okay? Most of the boat is not going to be underwater. Most of the boat's going to be above. But the part that's being displaced is just the part that's underwater, which kind of makes sense, right? All right, so density and buoyancy. This is why I made you go through those density problems. Density is the ratio of the object's mass to its volume. The formula is density equals mass times volume. In our class, the units we're going to probably use are grams per centimeter cubed. Water has a density of 1 gram per centimeter cubed. And steel has a density of 7.8 grams per centimeter cubed. That's just for a reference so you can compare. If an object is less dense than the fluid it's in, it will float. Okay? So things that float would be like wood, wood or balls or something like that, right? If the object is more dense than the fluid it is in, it will sink. So steel would sink in water. A pencil is going to float. Remember that? Two forces act on every object in a fluid: weight, weight, and buoyant force are the two objects that the forces that act on a object. So you have the weight pushing down on it, or the density, right? And then you have the buoyant force pushing up. The force of gravity is equal to the weight of the object and it acts downward. And the buoyant force equal to the weight of the volume of displaced fluid. So, acts upward. So buoyant force acts upward, weight pushes down, acts downward. When the buoyant force is equal to the weight, an object floats or is suspended. When the buoyant force is less than the weight, the object will sink. Okay? Now, suspension or suspended is when an object has the same density as the fluid it is submerged in, it will be suspended in the fluid. Buoyant force on objects equal the object's weight, basically. So submarines have these ballast tanks that they can add water or take away water to make the submarine sink or float or submerged, or how they dive down or they emergency blow up, stuff like that. And again, in the book, it's a really good picture and explains. All right, so sinking. If the weight becomes greater than the buoyant force acting on an object, it will sink. So if you have hull damage in the ship, you're going to get a lot of water in the hull, and it's going to become the weight is going to become greater than the buoyant force, so it's going to sink. Now, a heavy ship's hull is shaped so it displaces a large amount of water, creating a large buoyant force. Objects float better in dense fluids, and the denser the fluid, the greater the weight displaced. It's easier to float in very salty water because it's denser. Okay, so I guess I have just done section 3. All right.